welcome back to OBINexus Computing. Now, this is the GitRaf playlist. GitRaf playlist. GitRaf is an extension for Git. GitRaf stands for, if you have Git FTP, Git File Transfer Protocol, for storing files in the cloud for systems, you're using SSH to things like Ionos Cloud or with FileZilla, or from local to systems. You have GitRaf to track changes over Git protocol. Secure to track file systems. Git is a version control system, so you can track files and update versions. It has all the tools to monitor versions too. But you got Git. Now we got GitRaf. GitRaf is an OBINexus project on github.com/OBINexus/GitRaf. GitRaf stands for regulation as firmware. Regulation as firmware. What does that mean? Okay. GitRaf works on three principles. Regulating firmware. The problem with firmware hacks or exploits, when you build a system and then you encode that code in silicon, hence the motherboard or the BIOS, you got a little CPU and you double up the BIOS, the basic input system. GitRaf principle allows for dynamic updates to without symbol for server X, which is Systematic version extended system. GitRaf allows you to regulate updates to your firmware, BIOS, motherboard, phone, any device you have. It's based on the Rifters philosophy, but GitRaf is a developer philosophy. So what that means is you develop and then you do that to your silicon. Using decorators as policies and wrappers as policies to perform some kind of application. When you execute a decorator, wrapper for the function, whether in C or Python, you really execution of something called a policy, because that policy ensures that function execution context is met. That function executes with some boundary, which is a policy. Now, what OBINexus computer wants to do, we're trying to implement policies for production systems. The sorry not sorry process means that I am not sorry. Run this test. When you do that such a policy equals sorry not sorry, or human as compliance cycle or hack for human in the loop systems, where HITL, HITL stands for human in the loop, people or stakeholders in the loop that have risk or rewards in that system. Which is called a stakeholder. Anyone that has risks working on that project has a risk to that project. Anyone that can make something to that project can give it. This is part of the milestone seeded investment. Which is why I'm happy OBINexus actually taking investment opportunities. We don't just take up investment your own money. We have to prove this. So for every stage we are complete for that project roadmap, we achieve something. That's a milestone for doing done. Based on the gating model, which I'll come back to. GitRaf is regulation of firmware. It allows us to do that and give us silicon. What is a silicon project? By silicon I mean like a hardware project. What is software? What is the way you get a grant or research and development based on the business model. You got to understand that if you're working with someone, the legal team or the business model, or this is business model and business practices that force the policies. So again, to just make sure to make the code sovereign, cultural appropriate for China, Japan, anywhere we ship our code. GitRaf is a contract for developers to comply with policies like HITL. Or no ghosting policy. I mean, you can't ghost us. This is a project we invested in. This is a contract you signed. No ghosting means like you can't ghost us. There's no ghosting here. You can't leave us midway and claim, man, we're gonna take legal action. There's no right to disperse the project. Or sorry not sorry. Sorry not sorry means I'm sorry for myself, but I'm not sorry for you. So you have to do your part as part of the project. You're a stakeholder. If I do my part, and then everyone is content. With the gating principles, I'll come back to that in another video. So, but my business work on HITL. So if I have such a GitRaf, that is policy hack, human compliance cycle, they must be able to return to that project and comply with the continue, breathe, take, and achieve what they need to do. And we got the human on the loop systems, which are for operations. Humans are monitoring that. This is the monitoring procedure for that project. Checking whether what is the test things that consider operations are things that are ongoing. They have to constantly maintain for that service, such as access, research, development, or reform. And make sure things are stabilized for that foundation. And projects are things you work on for a long time to get some deliverable outcome. All projects are all projects are all projects are all operations are projects. All anything you do in the real world is an operation, and all operations are projects. Not all projects are operation. No project is just like a end goal. Maybe a mission evolution project, an art project. Maybe not an art project. Maybe an art project. Maybe it's a code project. Maybe a music project. But your goal is to achieve something with that project. You attain something from it. Maybe it's a new track, a new album. This is what it is. Maybe a new character. And that's what I mean by so you got human on the loop systems. You got the stakeholder compliance. You got the people who are adversarial mitigating. But I will always go by give raf now. So when you have the budget polyfill factor, you really enforcing project for production cases for your business. You can use the macro system to enforce such policies. So you can see us. But the policies are QA bound. That means quality assurance. That means true positive, negative, false positive. We use the QA matrix to assert that's the term of quality assurance. I think I did say this before in another video. But just have to get back to it. But I want to emphasize something here. Okay, so I'm going to take it on the screen and start to show you the GitHub, the GitRub, the README for it here on GitHub, github.com/gitraf. Okay. One second. So this is like the old saying. This is a GitRaf. This is GitHub repo. I'm showing you how it works. So this is the governance trilogy. Who governs the governor? Who has the final say? What if two players fight? In GitRaf, in code, we're trying to what GitRaf is. It's git space raf or git space ftf. It's a command. It's an extension to git. So this is negative desk teams on authority vibe base. Who gets the vibes. Who can do. So when you want to open a repository, when you want to push a code, you're meant to do something. That's what GitRaf does. It's meant to allow you to push production ready code, regulated code, or things you can maintain. Now this is rough answers. Regulation by competence. That's the first principle. Every dev has a critical transaction, which is called an oral seal. I'll come on to oral seal later. But we're gonna try to understand. And oral seal is just an entropy sum. It really flattens the entropy distribution among the state space. Every policy enforced by the RAF system, whether you use GitRaf with the policy flags, is contracted, and this one is contracted from the RAF answer. It's regulation as firmware. Everyone gets a say and to do some policy to mitigate some problem. The policy tag, the entropy checksum, which is like the checksum to see whether the entropy has been validated or not. Everyone accepted the efforts to continue the project for that development, testing, staging, or whatever you're trying to develop, based on the principles of development. That's what GitRaf is. It's just a command to invoke policies, add commits, for staging, but this in a manner that is based on the RAF principle, regulation as firmware. Okay, now we got problem 2. Who holds the power to over the rule makers? Rule makers are people who push codes, change dependencies, things like that. Rule makers are people who are like do stuff, so we can have this thing, got attacker risk, all policies must pass vector-based validation. Every policy you have in GitRaf, whether you make it or not, must pass something called vector-based validation. Whether there's a vector, maybe it's an oral seal, which is an oral seal is just a computer function that flattens entropy distribution amongst the state space. You know, every time you have a oral checksum, it's like there's no entry point to that project, whether it's a safety control system or hospital system. You know, GitRef shows that the entropy is distributed. The entropy is distributed, and there's no single point of entry for the public key cryptography, which is asymmetrically bound cryptography system. So it is an attack risk, which is like it's a GitRef attack risk, rollback cost, or stability impact. You know, it uses domain calculation to analyze or to ensure that the algorithm is sound, to make sure there's no attack point. Dimensional game theory again is about dimensions. This is an attack dimension or defense dimension or offense dimension. And that is using governance is governed. You know, everyone has a task to do it. You know, this is called sign divergence. So if a policy leads to entropy distribution, it gets blocked, rolled back, or rewritten. Okay. So that's it. Problem 3. Final sale. Final sale. When policies clash, two valid points, one right hand punch. Who wins? Yes. Telemetry based resolution. See that's the thing. It's like this is very important to understand. It's about resolving policies. When policies telemetry based, when policies calculate, vectors are scored and compared. Not with max wins, not ego. If it's still inconclusive, telemetry speaks. Who's actually making the most policy. It's about whose policy is more consistent. Governance is not about winning arguments, it's about winning the works in production. So you have a good rap score. People trust you. The system trusts you. The math is sound. It's using something called oral seal to do it. Okay. So who governs the governor? So who governs the governor? The one with oral show entropy. Entropy seals, oral seals are really because of oral seal, it's like oral it's a micro algorithm. It's like distributed entropy amongst the project to make sure there's no point of entropy. It's used to look at Shannon entropy based on correctness, hardness, and soundness principles. So it really states the concept is of correctness is the algorithm is correct. You can check it. It's correct. The system knows it's correct. You can check its valid inputs based on it works. It works based on the QA matrix, the quality assurance matrix. And you got completeness. Correctness. You got correctness. You got soundness. Soundness means you can't feel the system. So I'm going to test my cryptographic algorithm for QA bounds, true positive, true negative, false positive, which was an oral cell. And then you got hardness. It's hard to solve in like an elliptical curve. It's hard to solve in real time, but it's really so hard to solve. Yep. Yeah. So this is called a rift. So like Act 1. Yep, this is called a rift. I won't go to Act. Read the Act if you want. But you can go there to GitHub that comes with opening for graph. But the rough principles are really about making sure that your project develops without someone adding a malware to it, and without you knowing, because that's been a big problem with some software I've seen online. I think it was and this is GitRef. It solves that problem. It acknowledges that this one makes a report, and the policy is less, and they're trying to invoke incorrect policy. You can trace back that this policy is going to be violated because it's a policy chain. It enforces and it's traceable, and you can then remove that individual, whether it's open source or not. And this is GitRef. You guys should try to use GitRef. Yeah. So I'm going to go to documentation now. I'm going to show you one more thing. It's a bit messy here. Oh, this is a biometric foundation. Is this a spec? It's kind of yep, this is spec here. I need it. So this is a specification. You can read the specification if you like, but the entire specification, I suggest you read it if you're really studying how this control system works. But what I'll show you now is the one-way function that works. So see this document. I wrote this in a hurry, but it's like it's like this is a perfect number. It is a prime number distribution to address ciphers one-way function, which is a one-way function implementation, which is an oral seal, using asymmetric cryptography. But this is the document for the it's the code hidden cipher for one-way function integrity checksum. What is a one-way function? Can you get a function with an input? You cannot reverse. it's impossible to resolve, which is known as a one-way function. It's easy to compute, for the people. It's hard to solve, like, verify, which is just the inverse of it. And this is my solution to it, which is the oral seals and entropy checksum. Okay, thank you and goodbye. But GitRap is gonna change the way we work, the way we do stuff, and how things behave in the real world. It's control bound. You can read it, you can use it, and you can read the documentation and use it how you see fit in your project, your open source projects or closed source NDA projects, any way you feel fit. Thank you and goodbye. This is OBINexus signing out.